Thanks for coming out today. We're going to be continuing on with discussing circuits and building a circuit in 123D circuits. I will do a brief review on what we did last class, and I'll go over it pretty quick, so don't fret if some of this looks familiar. That's exactly what I'm looking for here. So last class we discussed circuits, and we started by discussing the couple of parts of circuits that most circuits will have. We discussed our voltage source. So in this case, the battery. It's going to produce the electrical current that'll flow through your circuit. We discussed the current, which is the electricity that will flow through your circuit. And we discussed resistance, which is a component that will resist the flow of the current, and not let as much current through at a time. So we did discuss briefly about schematics, which is what we're going to be looking at a lot later today. So keep the idea of a schematic in your brain. Once we discuss circuits, we discuss breadboards. So a breadboard being a way to wire up a circuit without having to solder it. It does make electrical connections, minus the soldering. So we talked about the vertical and horizontal buses. These two vertical buses on each side will be connected to each other. And what I mean by that is there's all these little holes. All the ones that are running down the side are connected, so the positive is connected to itself, but it's not connected to the negative. The negative is all connected to itself. And similarly, this positive is connected to only itself, and this negative is only connected to itself. We also talked about the vertical buses, which are these 5 holes here and on this side. The horizontal buses are connected to only the ones next to it, but this break in the middle of this breadboard here means that the horizontal buses on this side are not connected to the horizontal buses on this side. So what we did with that is we started doing a very basic circuit, specifically this light circuit, in a software, a nice free online browser-based, don't download anything software called 123D Circuits. And again, if you weren't able to watch Monday's webinar or attend for whatever reason, you already have a login for 123D Circuits. If you have a Tinkercad login from a couple of weeks ago, you are able to use the Tinkercad login to get into 123D Circuits. So the URL for 123D Circuits, if you're not familiar, which I'm actually not familiar myself, let me check real quick. I believe it's 123d.circuits.io. So we will be using this today, so I will go ahead and send you the link if you weren't able to try it out on Monday. So we will be using that. After that, we discussed a little bit of how to navigate 123D circuits. So specifically, when it comes to the breadboard circuit, that's really what we worked with. Once we got into the breadboard circuit, we see a breadboard. We talked about how to navigate the view, which is very similar to Tinkercad. The biggest thing you're going to see as a difference is rotating items. And there's a couple ways that you can do that. First being by clicking the R key on your keyboard, or in the, let's see if I can find it. I don't know if I can find it on this one, but I'll show you later if you're having trouble. There is a button in the upper left-hand corner to let you rotate stuff. So from there, we did not necessarily use the Arduino like this shows you here. We used a battery to start our circuit. And if I can find my own, am I logged in? Yes, I totally am. We ended up putting together the battery with the breadboard, an LED with the breadboard, and a resistor of an appropriate value onto the breadboard to make a circuit that, if you get it to work successfully, you will see the light up. And if my thing will work, here we go, start simulation. If it's working successfully, your light will turn on. It looks like it's exploding, but it's not actually exploding. It just is indicating that the light is on and bright and fantastic. So based on anything that I just went over, does anybody have any questions? Anybody having issues with getting on to 123D circuits or anything like that? I'm only asking because I see a couple names that did not attend my webinar Monday. And I don't know if you attended a webinar at all Monday, so I just want to make sure that you're here with us before I just go completely over your head. So y'all don't have anything for me. And if you do have any questions, don't be afraid to stop me. It's a smaller class today, which is kind of weird, but I'll need to figure out what's going on with that. Goodness, I'm so sorry, guys. My throat has been going crazy all day. Allergies, I guess. So let's go ahead and I will start with the lesson for today, which is titled PCB Design with 123D Circuit. So I don't know if y'all remember, I mentioned briefly last class that a PCB stands for printed circuit boards. Whenever you're finished with your seat perches, I don't know if you're finished or not yet, but once you're finished with that, your next slab will include creating your own PCB, and Mr. Dubik will be printing them out on his fancy machine that'll do that for you. So that's why we're doing this. That way you can gloat to all your friends that you have a nice circuit board that does some cool stuff, and they don't. Ha ha ha. Anyways, so our goal today, again, is to understand the schematic and board views within 123D circuit, and we will be making our first PCB. So I'll be showing you some of the different views, because last class we used 123D circuits. Let me see what's going on here. I'm trying to remember, sorry. We use 123D circuits electronics, but today we're going to be using something different. It's going to be the PCB design. But they have a very similar interface, and I'll show you when we get there. So if you haven't already, I do want you to go ahead and navigate to 123D circuits. You don't have to open anything up yet. Like I said, we're not going to be using the circuit we built last class as anything more than an introduction to this software. So without any further ado, I'll get started. We will add elements to the schematic, we'll design a circuit, and we probably today will not do this, but next class we will be finishing in a board view. The board being the actual physical circuit board. Alright. So I am going to assume that you are at least slightly familiar with 123D circuit, as in you can you've either were here on Monday or watched the video, or you can wing it well enough just based on what I show you, but I'm hoping that you either watched the video or were here. You'll be making a simple circuit today, and afterwards we'll be able to export the files so that you know how to do it when you make your own design for printing. So, another review. I didn't make this presentation. We will be using this because it's easy to use and free. It's pretty powerful for what it's worth. It has a whole ton of components, and it is compatible with Arduino. So if you do have an Arduino at home, this software is really good because you can emulate circuits without having to buy all the components and stuff. That stuff can get expensive, and if you can test it beforehand, that's really ideal. That's kind of the case in the entire engineering world. And our goal for the end of the day, we are going to be creating this guy in 123D circuits. So, you think you can handle this, y'all? Questions, objections? I think you can do this. Y'all are skilled. And by the way, I'm totally just kidding. We're not going to be building that. um, I don't even think I could build this. This is crazy. But I'm glad somebody caught that. And I was hoping to troll somebody, so wahaha. Anyways, again, if you haven't logged in, go ahead and log in to 123D Circuit with your Tinkercad login. In the upper left-hand corner, you'll see these 3 lines. I'd like for you to click on them. And then click on PCB Design. So again, 3 lines. Once you've logged in, click PCB Design. If this is your first time logging in, or actually I don't know if it's quite the case, but for sure on your first time you'll see something that looks like this. Unless you really want to watch the video, we're going to click on this blue New PCB Design. We'll be working in here all class. When you do that, you'll see a page that looks like this. Notice that it looks suspiciously a lot like the electronics build area. The main difference here is a couple different options in the upper right hand corner, but there is no circuit or a breadboard waiting for you. There's not a breadboard because we're not working with the breadboard. We will be actually creating a schematic first before we do anything with the board. And today it's probably just going to be the schematic, to be honest. But it's okay. Gotta start somewhere, right? So again, click on New PCB Design. And takes you to the schematic view. Again, no breadboard, but there is all sorts of options in the upper right-hand corner. For now, I don't really want you to mess with anything. It should default to the schematics view. You can tell if you hover your mouse over it. Don't worry about PCB view or bill of materials or anything. Any questions so far on getting to this point? Okay. Underneath that line of stuff that I told you not to touch, there's going to be a button that says plus, and then a button, oops, I went to the wrong one, and a button that says components. Now I'd like for you to click on components. Okay, I'm in the right spot. I'm going to click on components. If you recall what that did from last class it would, at the bottom of your screen, a little window is going to pop up with all sorts of different components. And it's going to do the same thing here, but you might notice that the components look a little bit different. Last class we had physical components as you would see them on a breadboard or on a circuit board, but this time we have just sort of line drawings. These line drawings tell you, or sort of show you, what the corresponding physical components would look like in written form. So I want you to just take a second and scroll down to see sort of what all this stuff is. There's a lot of stuff that I haven't gone over, and you have probably no idea what they do, like why on earth is a crystal in an electronic schematic? It does something. It really actually does. It's really cool, but we're not going to be using that. So take a second. and get confused because none of this stuff makes any sense to somebody that's never done this. And half of it doesn't make sense to me. I'm not an electronics person by trade, but I took a class on it. But crazy stuff. Don't worry, we're not going to use most of the ones at the bottom. Well, we're going to use one, but not all of them. Alright. So, long story short, a schematic is what an engineer would use to design the layout of a circuit and share that design with other engineers. It's like a map of all the components in a circuit. Now, keep in mind, the circuit that is represented in a schematic will not necessarily be laid out the same way. They're literally just meant to make an electrical circuit readable. So if I were to create this circuit that you see on our screen right now, this whole crazy big thing, it's not going to look like this. It's not going to have these perfect right angles. It's not going to have this just perfect, simple to look at view. If I were to build this on a breadboard, it would look awful. Absolutely atrocious. It would just, there'd be wires sticking out and like, basically what I'm trying to say is that a schematic, while it is showing you the exact same thing that you would put on a breadboard, it's not going to look like this. It's not pretty. Sometimes engineering is not pretty. So just prepare yourself for that. I don't know if you'll be doing any physical breadboarding this semester beyond what we just did last class, but yeah, just keep it in mind. As an aside, one of the schematics I showed you earlier, this guy here, I have no idea what it does. I don't know what the one on here does, but schematics in its own right are kind of really beautiful. So I literally just went to Google Images earlier and searched schematic and saw all sorts of different schematics. Somewhere on here I saw a schematic for, where is it? For a theremin, which is an electronic instrument that sounds really, really cool and spooky. Where is it? See, like, somebody would have to look at this in the field and be like, oh, okay, that's why the electrics are not working. Where is it? Here we go. This is a theremin here. This is actually a relatively simple circuit. I know you're calling me out. Nuh-uh, Miss Saunders, that is not simple. It would probably, with testing, probably take an hour or two to build. I actually built this in one of my old camps. Not this one, but one like it. But really cool stuff. And this is actually a schematic for an Atari 2600. So, if you wanted to build your own game machine, just get all these components right here. Bam, you got it. But I digress. I just find it really interesting to look at this sort of stuff, even though designing it or building it is in its own right a crazy thing to do. Not in a bad way, a good way. Anyways, so let's go ahead, and the first thing we're going to be doing on 123D circuit PCB is start with the first three icons that appear. We got G and D, and we've got two icons. Okay, fine, Mateo, you win. Give me 1 second. G and D, we've got VCC and another VCC. As Mateo pointed out, G and D does stand for ground. So if you remember, a circuit is always going to flow in a circle from the positive terminal to the ground. That's how current flows. If a circuit is not complete, meaning that there isn't voltage coming out of the positive terminal and going into the ground, your circuit will not work. Right. So in this case, ground, we're more than likely, what's a good way to put this? Again, ground can be found on a battery or an Arduino, but the way that we're going to do this a little bit later is going to be kind of cool. So we're not necessarily starting with the battery or anything, just a good old straight up ground. Now what about VCC? Not so quick on that one, were you, eh? You don't have to know what the initials VCC stand for, but take a guess at what these two items are. They're the same thing. They have the same name in this case. But if we have ground, what are these going to be? A hill and an arrow. That is what it looks like. But more specifically, on a schematic, there we go. It's going to be power, it's going to be the positive terminal, it's going to be the anode. All the same thing. It's going to be from where... Alright, I'm going to bite my lip when I say this because I'm going to really confuse you in a second, but it is going to be the positive terminal. Now specifically, VCC is going to be a power source, usually a battery, but it could be something else. For one circuit, you can use either one. Alright, but you want to be consistent. So if for some reason you have one voltage source and you want to add a second one, you don't want to add the second one. If you use this one first, you don't want to add this one as a different source. Remember, you can name your components in 1, 2, 3D circuits. You want to be consistent with whichever one you use. So we don't want to mix these two. We just want to keep one per schematic. So here's what I was talking about confusing you. VCC stands for voltage collector. Electricity... I'm sorry, I'm trying to think of a way to say this without really, really confusing you, and I might just skip it completely. I'll tell you anyway, but take it with a grain of salt. Electricity flows from negative to positive. So like think in a battery, voltage is going to go into the negative side and come out the positive side. That's why the positive is a voltage collector. That's sort of counterintuitive to what I've been telling you, where voltage flows out of the positive and to the negative. That's why I was hesitant to tell you about this. But back in the old days, ground used to be represented as VSS, or voltage source. So for our purposes, electricity is going to flow from positive to negative. If you go into electrical engineering, that's not true. So that's why I was getting all weird for a second there. Anyways, what we're going to be doing is we're going to add one of both. And when I say both, we're going to add one VCC and one ground. You want to put the voltage somewhere near the top and the ground somewhere near the bottom. And we'll worry about making it look good later. So remember, you don't have to use the hill. You can use the arrow. I might as well use the arrow just so I can show you both ways. So we have voltage with a default name of 1. And you'll notice if you have aligned your voltage and ground, which I would prefer you do, just for good measure, you'll see that a line will appear showing you that they're along the same axis. So again, notice that voltage is named 1, ground is also named 1, but because they're different components, they can have the same name. Do we have any questions on that so far? Is this a valid electrical circuit right now? Obviously there's not much to it. But can we have a current through this at the moment? The answer is going to be no. Even though we have voltage and ground, we have nothing at all connecting the two. So alright. Voltage, ground, life is good. The next thing we are going to do is add a couple of resistors to the design. You named your power source Supersonic Smashing Power. Alright, so I want you to know that you will be using that name later on as well. So you can keep it like that, but just remember how you spelled it and everything. Or be able to reference that. I mean, you can name it whatever you want, honestly. I'm just naming it 1 because it's easy. um, yeah, anyways, we're going to add a couple of resistors. So in components, we got to click on components. It's going to be right next to our voltage and ground sources. And we're going to add 2 different resistors now. They are enormous. I don't know why. We can fix that later. We want to keep them relatively aligned. So if you remember what I said earlier, we're going to put them next to each other, and a line will show you where the alignment axis is. We want to put them in line with each other. By default, these are going to be named R1 and R2. I think you can rename them if you want, but again, for how simple this circuit's going to be, you don't really need to rename them, unless you really, really want to. Is this a valid circuit? Would stuff happen if I try to simulate this? Correct. This is not a valid circuit. With 123D circuit PCB, you do not want to connect your components until you've made a complete circuit. When I say that, I mean you want to make sure that you have everything included so that you don't have to start deleting connections. That's why we're doing all this stuff first. Putting all your components out before we even think about making it just one single circuit. So let's see what these values are for your resistors. I cannot remember. So again, we've got to make sure they're next to each other, but in between the voltage and the ground. Do we not include what the resistor values are? Let's go with 330 ohms. So for each of these resistors, I want you to select them. They'll be bolded. Change the resistance from 1 to 330. And in this drop-down box right next to it, we're going to change this K and this ohm sign to just regular ohms. We're going to change both R1 and R2 to be 330 ohms, not K ohms, just regular ohms. So as an aside, I didn't mention this last class. This symbol here is Greek. It's omega. But in electronics, it stands for ohms, which is a measure of resistance. All right. So the next thing we're going to do is add ourselves an LED. You will have to do some digging inside the component search for this LED. The name of it's going to be LED. It's going to share a design with some components. So it's going to have this triangle, block, arrow situation, as you can see. But we want the one called LED. We're going to be adding 2 of these LEDs directly underneath each of these resistors. So I'll talk about that in just a second, but scroll on down, 4, 5, 6, 7. Where is it? Did I go past it? That's why I said doing some digging here. For the one named LED. And I guess you could search it if you wanted to, but LED will be close to the bottom. We're going to be adding 2 of these once again. Actually, hang on. I know you can put LED in search, but that just makes too much sense. So, make sure that these things are not connected quite yet. Make sure you don't connect end to end. We'll do that very soon, don't worry. But if you weren't here last class, real quick aside about this little icon here, the diode, or the LED icon. If you look in the components, near the top, on the top actually, there is one called diode. Remember, LED stands for light emitting diode. A diode being an electronic component that will make electricity flow only one way through it. So electricity will flow in the same direction as this arrow. So boom, boom. Electricity will be blocked if it tries to come in from the other way. What makes it light emitting, at least in a schematic, are these 2 little arrows. So with the diode, electricity can only come through one way. In an LED, when it comes through this direction, it'll light up. So on the pop-up box for the LED, you can also change the color of it, but it really doesn't matter since we're not going to be doing any printing with this. So don't worry about changing the color unless you really want to. So again, you want to make sure they're in alignment. And there's one underneath each resistor. Again, the names do not matter right now. Now what I want you to do now is to make sure that everything is pretty well distance apart. We're going to be adding one more component. So if all your stuff is really bunched together, we're going to move them just a little bit. But we want to make sure that these components are still aligned with each other. It doesn't have to be perfect or anything, but just enough room here. I'll actually move my ground down some. So make super sure that everything is all good. If you're just now tuning in, you are super late, but we are going to be working in PCB. We're still working in 123D circuits, but we're not using the breadboard. Today we're using the PCB maker. Yeah, I'm totally talking about you. It's okay though. If you were here last class, which you were, it's pretty easy to get caught up to where we are right now. We're just making this circuit here in the PCB maker. It's not quite a circuit yet, it's just sort of a bunch of components, but yeah. So we need to make room for one more component. It's going to be in between the diodes and the ground. So it's going to be somewhere around right here. So you want to make sure that there is just a little bit extra room for this extra component here. We're going to be putting in a potentiometer. Has anyone ever heard of a potentiometer? I doubt it, but you've definitely used one before. But I am still intrigued to see if anyone has actually had some familiarity with that. Alright, no? So I'm going to explain to you what it is, and then I'll tell you where you've probably used it. So again, or which one are we using real quick before? Actually, don't put it in yet, but sit tight. We are using a potentiometer next. Specifically one called Potentiometer Standard Panel Mount. We'll be adding that in a second. So potentiometer is a little bit more complex of a component than what we've used so far. But basically, it is a simple resistor. But it has two ways for electricity to leave instead of just one. So remember, with the resistor we had input, so it's part of the circuit where electricity is flowing in, and then part of electricity that's going to be flowing out. We're going to have one part of electricity coming in on a potentiometer, and two ways for electricity to come out. There is a knob on potentiometers that you can turn to adjust how high or low the resistance is coming out of each side. So turning this knob will increase the resistance on one side, while it decreases the resistance on the other. And so more or less electricity will be flowing out given the same input. So basically it's like a lever that'll change the directions of a train depending on how it's the position it's in. Sort of like that. But it's not absolute. It's not like you're going to completely stop electricity from coming out of one. It's going to be some ratio, so maybe 60% is coming out of one, 40% the other. You can adjust it very easily. It's a little bit touchy. So again, in the components, we're going to be adding in the potentiometer standard panel mount. But before you place it, we want to rotate it. Whoops. We want to rotate it like this. So that the arrow is pointing up into the zigzaggy resistor line. Alright, so notice that if you hover your mouse over it, one end there's a red dot, another end there's a red dot, another end there's a red dot. So 3 pins on the potentiometer, 3 red dots indicating where things can be connected. Alright. And if you forgot, the way that you rotate is by clicking the R button once. In PCB circuit, it will rotate 90 degrees, unlike in the electronics, which only rotated at 30, I believe. So it's going to look either like this or like mine, the only difference between the two being the icon we use for voltage. Any questions on this so far? Alright, we're doing good, y'all. Kicking some butt. Alright. At this point, we can finally put everything together. So for this case, we're going to start by hovering over our voltage source, where that sort of at the end here, so the red dot pops up. We're going to click on that, and we're going to then click on the close end of R1. And what's going to happen is going to connect each other. You'll notice, though, that instead of connecting diagonally here, that it's going to default to 90-degree angles. Why would it be beneficial in a schematic to have these 90-degree angles instead of these sort of diagonal lines here? Do we do it because engineers just like right angles? Is that it? We do, but that's not why. Any thoughts as to why schematics would use right angles? Yeah, exactly. It's so much neater and so much nicer and easier to read. And as we go through this, I will explain a couple more little things that 123D circuit PCB does to make it easier to read for us and to make it look more like a real schematic, which this will be a real schematic. So let's go ahead and do the same thing for R2. Click once on the voltage source and once on the other end. And once again, it's going to default it to a right angle. Alright, so we did that. Now you'll notice, when you do this, that a black dot is going to appear where the two connections separate from the voltage source. So you see this black dot here? This is yet another thing that schematics require. The circle represents a connection and it's for readability. It just makes it look a lot nicer so that we can tell, alright, there's the same voltage going on all the way through all of these wires, but these two wires join before the voltage source. So it's just a convention and it looks nice. So let's go ahead and finish up that circuit. So we're going to connect each resistor to its corresponding diode, each diode to either end of the potentiometer, and the potentiometer to the ground. So let's go ahead and do that really quick. Everything looking connected for y'all? Is life all good? I'm going to continue if there are no objections. Alright. So what is this circuit going to do? Any ideas? So this will look very similar to the light circuit we made last class. The big question here being, what does the potentiometer do? How is it going to change this circuit? The circuit will light up the LEDs. You are right about that. But if you remember, the potentiometer changes the resistance of either side, either output side rather. Meaning that if you turn the knob, one side will have a higher resistance than the other side. I don't think I mentioned this last class, but LEDs in that LED circuit that I showed you will be lighter or brighter or not as bright depending on how high the resistance is. Right now our resistors are 330 ohms, these R1 and R2. They're both the same, and that's relatively a low resistance. So again, if I click on the resistor, you'll notice that it's just in units of ohms, but see there's kilo ohms, which is 1,000 ohms, mega ohms, which is 10,000, and giga, which is a million, something like that, I can't remember exactly. But this is a fairly low resistance. Would the lights be, or would the light be brighter if the resistance is high, or less bright? If I change this ohms to kilo ohms, would the LED be brighter or less bright? It's not going to be brighter. It's actually going to be less bright because the resistors are limiting so much more of the current from entering in the diode, and so therefore these LEDs will not get as bright. So with this potentiometer here acting like a variable resistor, our lights will still light up, but depending on the potentiometer's orientation, one side will not be as bright as the other. And the resistor thing is a little bit of a trick question. You have to sort of, at least with me, I had to think about it really hard and take lots of classes on it to understand exactly why it behaves that way. So the higher the resistor, the dimmer the light. So if we wanted to determine how everything is flowing, what happens at the split right here is that the voltage, some of the electricity is going to be flowing into R1, and some of it's going to be flowing into R2. So what we're doing here is we are splitting voltage in half and still letting everything go through the resistor and then the diode, and finally into the potentiometer. And so once again, this is where it gets confusing. Even though I've been telling you voltage flows one way to the other, it's actually the opposite, which is why the arrow is pointing from the ground into the potentiometer. Confusing, I don't like it, that's why I teach it the other way. So let's see. Alright, we are missing a very important part of this schematic. Now the schematic itself is okay, but we'll need to add it in, an extra part in, before we can consider this PCB schematic to be done. So we're going to add one more component. It's going to be on the very bottom, or second to the very bottom, sorry. And it's going to be called connector screw terminal block. Second row from the bottom, we're going to add that in, and we can just throw this somewhere along the side of our schematic. Connector screw terminal block. Or we can search for it. Either one. So you might see this in other schematics, you might not. But what it is, it's sort of like a breadboard, but it uses screws to mechanically and electrically connect the wires to your PCB board. So they're called screw blocks because there are little screws on them that will tighten the connection to ensure the wire stays in. So these are both mechanical and electrically used. So it's going to be used to connect wires to our circuit. But why? Why would we use that? Why would it be nice to be able to add wires to our circuit? And actually, I don't know if you have an answer for that at this point, and that's okay. We haven't, even though we've determined where our voltage and our ground is going to be located within our circuit, we haven't yet added a power source to this. By adding this screw block here, that lets us use or have the ability to use more than one different source of power. So maybe if we were to do this in lab, we would power it through a battery. But when you got home, you don't have any batteries. However, you have say a USB drive or an Arduino. This is basically a like one of those, what's it called? Not a socket, the other part of a socket. The male part of a socket, the power plug. It's basically like a plug. You can plug your phone in anywhere. Doesn't matter what your power source is. It's not a very good analogy, but point being, VCC and ground don't mean anything because we don't have a defined source. There we go. So the question, what are we going to use these for? Is it for a specific reason, or we are going to be building our own PCB in lab using one of those machines that Mr. Dubik has. I can't remember which machine it is, but the reason we're doing this is because we want to build a schematic and then we want to design our board so that we can print them in lab. That's why we're doing this. It's not like we're just doing this for funsies. It should be a little bit fun, but that's why we're doing it. This specific circuit we're probably not going to use, though. This is just practice. What are we going to use these boards for? I'm actually not entirely sure what you're going to be designing yet to be printed on these boards, but if I'm not mistaken, you will be designing them. It'll print. You're going to solder in the components and show off to your friends that I built this circuit board. Ha ha ha, look at me. So it's not a very good answer, but as to my knowledge now, yeah, that is my answer. So if you gotta go, that's alright. I will go over a little bit of this next class, and thank you for coming. But I do have a couple more things I'm going to do first before I end class. Still got about 2 more minutes, so underneath the screw, we're going to add a second ground and voltage to the circuit. But we want to make sure, again, that we do use the same symbol that we used up here, down here. So it doesn't really matter, or just put it like it is, sorry. So we do want to align them once again. You want to rotate your voltage so that it's pointing upward, or sorry, so that the lead is correct. So when I say that, I mean we don't want it to be upside down like this. Whoops, I did that wrong. We want to make sure, for mine, the arrow is pointing down. For if you use this one, we want to make sure this downwards line is pointing up. And you're going to want to connect them to the leads of the screw. So I'm going to do this really fast because it is 7. When we click on our voltage source, we want to make sure that it has the same name as the one that we've already defined up here. So up here I define my name as 1. Down here you want to define your name as 1 as well. Alright. So that being said, it is 7. So you are free to go if you'd like to go. This is all I'm going to go over today. We will continue with actually discussing making the board next class.